In this very short video, also associated with the book, I'm going to give an outline of the procedure that will be used to analyze each of the data sets in the coming chapters in both Frequentist and Bayesian frameworks. So we will always start by importing and examining the data, doing an exploratory data analysis, do a Frequentist fitting of the statistical model that will be fit to the data, do a Bayesian fitting of the same statistical model. We will assess the goodness of fit of the statistical model in each of the frameworks to the data, and then finally communicate the model output. So we start by importing the CSV data file. CSV stands for comma separated values, and this is a very short text file producing any spreadsheet program, Excel or Calc or whatever you want. And the result of the importation of the data in R would be to generate a data frame that will be the input for the data analysis and for the graphics. The second is to verify the scales of the variables, whether they are numerical variables or factors or categories, and converting them as necessary. Then the exploratory data analysis has several independent goals. First is assess which probability distribution or distributions, should there be two, should be used to model the response variable. This is essential to write the likelihood part of the model. Second is to examine the relationship between the response and the explanatory variables. And this will allow us to assess whether we need to consider interactions between explanatory variables. That is, these interactions between explanatory variables could be motivated either by previously existing hypotheses or by relationships found during the exploratory data analysis. Then we would characterize the data set, the response variable, by calculating discrete statistics, eventually per group, on a per group basis. And then finally, we would verify the degree of independence between among the numerical explanatory variables. This is to avoid including strongly correlated variables in analysis that would not only make it difficult to fit the model, but also give redundant interpretations of the findings. And then in the Frequentist fitting of the statistical model, we obtain, the goal is to obtain and interpret the estimates of the model parameters along with their standard errors and their confidence intervals. And then interpret the metrics, the common metrics of model fit, such as the adjusted R-square or percentage of variation explained, and the percentage of deviance explained in the case of the GLM. We will see to that later on. And then when appropriate, in the case of the Frequentist framework, we carry out a posteriori comparisons and interpret the results. And should we use model selection, we should compare the models using the Akaike information criterions and the Wilk likelihood ratio test to compare the statistical model fitted to the same data. I am going to discuss both the AIC and the Wilk's likelihood ratio test in coming videos. In the case of the Bayesian fitting of the statistical model, we obtain and interpret the posterior means of the model parameter, the posterior means of the model parameters, their standard errors, that is the standard deviation of these posterior distributions, and the 95% credible intervals. We must always assess the convergence of the MCMC algorithm and the degree of statistical independence of the sample parameter estimate retained in the chains. We need also to obtain and interpret the Bayesian R-square and other metrics of model fit. And in the context of model selection, we are going to make a very simple illustration. We should use a recently developed information criteria called the Watanabe Akaike information criterion, or as called by others, the widely applicable information criterion. Model selection in the case of the Bayesian framework remains very much, in my view, a work in progress. And in the case of the Bayesian fittings, we need to define the prior distributions of the parameters, always display them in plots, and we must always assess the influence of the priors on the results by doing a prior sensitivity analysis or use the prior predictive distributions. When assessing the goodness of fit, we should obtain the residuals, the appropriate residuals to make assessment of a model fit, and use these residuals. We will discuss which residuals and we need to get in each time. We should carry out a graphical analysis, and this will involve plots of residuals against predicted values, residuals against all the explanatory variables, the quantile plots or cuckoo plots, we will see to that. And we will also assess the influence of each data point in the model fit, for which we would use the Cook distances in the Frequentist framework and the Pareto case statistic in the case of the Bayesian framework. And in the case of the Bayesian framework, there is a fantastic tool called the posterior predictive distributions and their associated posterior predictive checks to evaluate the predictive capacity of the fitted statistical model. So in communicating the model output, we should always obtain and interpret figures or plots of the model parameter estimates, either the point estimates or the means of the posterior distributions, along with their 95% confidence or credible intervals in each of the statistical frameworks. And we should always obtain and interpret the conditional plots depicting the predictive relationship between explanatory variables and interactions of the fitted statistical model. So this is the essential procedure that I'm going to follow in all the remaining videos, each with specific chapters of the book. So in this very short video, I just outlined this general procedure that I hope will help you follow the procedure that will be used in coming videos. Thank you for your attention.